Hi everyone, this is our second of 2 weeks on single system designs. I'm going to talk about some alternative designs and then some issues related to reliability and validity this week. So, by way of introduction, if you remember from last week's lecture, in the single system design world, the nomenclature is a little bit different, so the labeling is a little bit different. In group level designs, we use X's and O's to denote times of observation and periods of intervention. In the single system design world, we use A's and B's, and as we're going to learn this week, we're going to add on C's and D's and E's and so on and so forth. So the A phase is always the baseline phase. The B phase is always the intervention phase, and then as we'll learn this week, if we start to add on C's and D's and E's and F's and G's, we're adding on successive interventions. So in an ABC design, you'd have a baseline phase, sort of intervention 1 and then intervention 2. I can give you a real generic example to that. Example of that, which kind of relates to clinical practice. But we see ABC designs in sort of counseling and psychotherapy all the time. So suppose there's a client working with a social worker with a common mental health problem, something like depression or anxiety. In the A phase, there simply would be some observation, no intervention at all. In the B phase, there might be an intervention like counseling or psychotherapy. And then what happens sometimes is that the client and social worker agree that counseling isn't quite enough, and so there's a referral made to a psychiatrist, and the psychiatrist might add some kind of medication. The addition of that medication would be something like a C phase. Now what we need to sort out this week is that C phase, does it replace the B, or is it in addition to the B phase? So there's sort of a way to think about this, and that's an A, then B, then C design, which would sort of indicate that the C intervention has replaced the B intervention, so the B intervention has been discontinued. There's a sort of second option, and that would be an A, then B and C kind of design, and that's really where the C intervention is added to the B intervention, and the B intervention sort of continues. My sense is that in clinical practice, it's often an A, then B and C design that's used. It's usually a second intervention that's added to support that first intervention. So we'll get into that a little bit today, and then we'll talk about some other designs, ABA, ABAB, and even the BAB design here a little bit, and then we'll conclude with some thoughts about validity and reliability. So again, just by way of introduction, this whole single system design thing is really about monitoring client progress and practitioner effectiveness. They're widely used in clinical practice. They're widely used sort of throughout healthcare. Remember, in a single system design, there's only ever one client, or only ever one client system. Most often, that's a single person, but there are certainly times when that client system could be a dyad or a couple or a family or even a community or an organization or something like that. The sort of hallmark of the single system design is that there's really no control. So there's no intervention control group, and we're going to come back to this in a second when we talk about strengths and weaknesses. The other sort of hallmark of the single system design is that there's repeated measurements of a dependent variable. And the dependent variable is also known as the target problem. So in the example I used a second ago, the target problem was a common mental health problem, something like depression or anxiety, but certainly just about anything could be adapted or sort of constructed as a target problem or dependent variable. Single system designs are easy to implement. They generate a lot of insight for the client system involved and typically for the practitioner, but their sort of primary weakness is that there's no generalizability. There's really no external validity here. They don't generate insight beyond the clinician and the client system involved, and that's sort of their primary weakness as well. So what we're going to sort of work through this week is how we interpret graphs, which we now know how to do in Excel. There is really no statistical method for analyzing single system design data. What we really do is analyze the change in the line visually, and we're really looking for sort of visual changes, and then this thing called practical significance, or you may have heard it called clinical significance. And that's really, does the line, the visual change in a line correspond to some change that's either reported by the client herself or noticed by the clinician herself, or both, frankly. And so that is a limitation as well, that we don't necessarily have that statistical test, but we're sort of relying on, client report and other stakeholder report as well. Measuring problems can be tough. Remember, the measures that we use typically are pretty unidimensional, because that's what they're designed to be. And if you're only using one measure to measure a problem, that sort of ignores problems that might be related. We'll talk a little bit about how we might get around that this week, and that's primarily through incorporating multiple measurements. So some of the other problems that we sort of run into when we get to measurement are things like reactivity, obtrusiveness, self-report, and social desirability bias. Reactivity, if you remember from the fall semester, is this idea that people notice a problem simply by completing a measure about it, and that happens sometimes. Obtrusiveness happens when completing a measure really interferes with a client's life. So it's a lot of work to do this. It takes time, right? And you have to sort of pay attention to the questions as you're answering them. And then, of course, the sort of most, well, maybe not most, but a significant issue with single system designs is this idea of self-report and social desirability bias. Oops, got ahead of myself there. So let me just get back to the right slide here. So, I mean, the big issue with self-report and social desirability bias is that people aren't accurately capturing, they're not accurately responding to the measure, so we don't have an accurate understanding of whatever the level of the problem or dependent variable is. So, the A then B then C design, or the A then B C design, let's talk about these a little bit. When typically they're used when an intervention isn't effective, and we need to add sort of another intervention. The useful part of these designs is that we can see how clients respond to either each intervention individually or a combination of interventions, and that's useful really for clinical practice. So, as I said a second ago, I think it bears repeating, each sort of successive letter in the alphabet denotes some kind of additional intervention. You typically see an A, then B, then C design denoted with a dash or a hyphen or something like that in between them. If there's no dash, or if there's only a dash between the A and then the B and the, and then no dash between the B and the C, that typically means that it's an A, then B, and C design. I know the vocabulary can be a little confusing here, and so I hope the presence or absence of the dash makes it a little bit easier to understand. So here's in this graph, this is a sort of a callback to last week with our fictitious person Simone, the amount of time that she spends on her homework each day. So along the horizontal axis, we have 15 days of an intervention. We've got 2 vertical lines, one at day 5, a second at day 10. And so the left-hand-most third of the graph denotes the A phase, a time when there's no intervention. It's the baseline. That middle third is 1 intervention. And in this hypothetical case, it's talking to a counselor. And then in the sort of final third, the right-hand third of the graph, we've got a second intervention, which in this case we're just saying is no cell phone use, maybe until homework is done or something like that. Then on the vertical axis of the graph, we have number of minutes spent on homework. And the idea here is to make some interpretation of which of the 3 phases is most useful if sort of the desired outcome is for Simone to spend more time on her homework. The most time spent on her homework is more than likely in the C phase, which is the no cell phone portion of the intervention. In this design, we've used, or what I've attempted to graph here is an A, then B, then C, which is to say when the C phase starts, the B phase of the intervention, or the B phase intervention is discontinued. So in this, again, in this hypothetical example, the access to a counselor stops when the removal of the cell phone starts. You could certainly imagine a time maybe, or another scenario where you would do an A, then B, and C kind of intervention, which would simply mean that in Simone's case, the counselor is used in conjunction with the removal of the cell phone. A couple of other alternatives here. So there is an ABA design, and that's a removal of that's known as the removal of intervention design. So those phases would literally baseline, intervention, and then return to baseline. And what we would hope is that the gains or the improvements made in the intervention phase continue after we've removed that that particular intervention. In the case of Simone, if we were to go, say, from A, B, C back to A, what that means is that we're giving Simone her cell phone back. She's not talking to a counselor because we're going back to the A phase, but we hope that she continues to spend as much time on her homework as she has in the B and the C phases. So we certainly could extend this ABA design into an ABCA design. And again, the sort of key part here is the removal of intervention and return to baseline. It's typically an ABA design is stronger than a simple AB because you can sort of understand the effect of both adding the treatment and removing it, but we need to think about sort of the ethics of ending treatment. In the case of a homework intervention, like with our fictitious person Simone, that might be fairly innocuous, but in something, in something like psychotherapy or clinical work or something like that, the ethics would probably be a little bit more significant. In removal of intervention designs, there is this thing called a carryover, and a carryover simply means that there's sort of some carryover effects of the intervention back into the A phase, or back into that return to baseline phase. And what that means is that we need to be on the lookout for sort of the after effects of the intervention, these carryover effects. That really means that baseline, that return to baseline phase has to extend for long enough in order to let those carryover effects wear off. So here I've put the graph up with Simone again. Again, 15-day sort of intervention or study period with Simone. 15 days along the horizontal axis, and number of minutes that Simone spends on her homework on the horizontal axis. In Simone's case, what's happened here is that the number of minutes she's spending on her homework tapers off after we return to the baseline intervention. And so what we could sort of conclude is that Simone really needs some support so that she's spending enough time on her homework. The ethical sort of practical thing to do here would be to provide Simone with whatever support she needs in order to spend this an appropriate number of minutes on her homework every week. And so the reason I'm saying this is that this is sort of how practice is this is how single system designs are supposed to be used in practice. They're really informing that sort of next phase of treatment. Okay. And so the next sort of extension of this would be something like an AB-AB design. And so you've got sort of this oscillation between baseline and intervention phases. These are also known as replication designs or experimental replication designs. So what we're really looking for in an A, then B, then A, then B design is sort of the presence of effects in the B phase and the absence of effects in the A phase. So we want to see positive change in the A phase, or I'm sorry, positive change in the B phase, and then sort of negative change or setback in the A phase, and that really helps to establish causality, and that helps us say that it really is the intervention that's responsible for that positive change. These are good designs because they rule out sort of alternative explanations for change, but they really have significant ethical problems. I mean, what are the ethics of removing it? Just think about the ethics of removing an intervention and then putting it back in simply to see if it worked. I mean, that's not good clinical practice, and it's certainly not ethical. There's also this issue of carryover effects, right? The effects of that intervention are going to continue into that A phase that's sort of in the middle of the study there, and then the effects of the baseline carry over into the B phase after you've restarted the intervention. So carryover sort of works both ways. I do have an example again, just with Simone here. You can see this time we've extended the study period out to 20 days, and we're using an AB-AB design with her this time, just to see what happens when we remove the intervention. And in this case, it looks like she's spending more time with the intervention in place. And so that really sort of would lead a clinician or a social worker to the conclusion that Simone needs some kind of intervention, some kind of support to spend an appropriate number of minutes on her homework. A BAB design sort of flips the script here. So a BAB design would be an intervention, then a removal of that intervention, and then a return to the intervention. So it's sort of a repeat of the intervention after the baseline. The strengths of this is that you're implementing an intervention immediately, so you're not asking someone to wait for an intervention. But it also doesn't give you really like a true baseline. That baseline is subject to some carryover effects that might be present after that first transition to a B, then an A phase. So we could use that example with Simone if we wanted to, and so maybe in this case we can see that she's spending much more time in the B phases, which are sort of the first third and the last third of the 15-day study period, displayed on the graph here. And we see that when we've removed Simone's intervention, excuse me, let me just get a drink of water. When we've removed the intervention, we see that Simone is spending less time on her homework, which is, again, leading us to this conclusion that Simone needs some help to spend an appropriate number of minutes on her homework. Multiple baseline designs are used when you've got multiple clients, typically with the same problem or similar problems, and who are getting sort of the same intervention. The sort of hallmark of a multiple baseline design, and sort of the way to think about it, is that you've got several A-B designs or several single system designs running in parallel. the notation for that is typically an A1, B1, an A2, B2, A3, B3, so on and so forth. And in this case, the 1, the 2, and the 3 that we've added to the A and the B is sort of what denotes different people. My sense is that multiple baseline designs aren't used all that often because it probably makes more sense to use some group level design instead of a multiple single system design. I think it's really easy to get this, multiple baseline designs confused with group level designs. The multiple baseline designs are really sort of used in primarily clinical settings where a clinician has a specialization with a particular type of client or a particular type of problem, and she's at different spots with each of these different clients, but sort of generally doing the same thing. Okay, so we've talked about a number of the different sort of prototypical single system designs. Let's shift our attention a little bit to issues of reliability and validity here. So remember, when we talk about validity in research, internal validity is really asking to what extent can we be sure that the intervention is causing the change in the dependent variable or the problem behavior in this case. And external validity is really asking to what extent can we generalize the findings of this study to the general population. Single system designs have very low external validity, and they're not used for that purpose. They're not sort of intended to produce generalizable knowledge. The quality of the internal validity really depends on what kind of design you've used. So AB designs are certainly have more internal validity than, say, an AB design, but they also come with much more of these ethical concerns that we have to sort out with. Again, my real sense of the single system design is that it's used to really track progress, and so things like the AB design and the ABA design are used most often in clinical practice because they're the simplest, they have the fewest sort of ethical concerns or ethical pitfalls, but they also probably have the sort of most threats to internal validity. So a couple of slides here. So when we're talking about internal validity, all of the things that we talked about last semester are sort of relevant here in, went too far, are sort of relevant here in the world of single system designs. So single system designs are vulnerable to history effects. And remember, history is something that happens outside of the study that affects things inside of the study. So if you were in the middle of working with a client and say the stock market crashed or there was a natural disaster in the area or something like that, that would certainly impact the dependent variable. Maturation is that idea that there's natural growth and change that happens over time, and that's certainly at play in single system designs as well. Then there's testing effects and changes in instrumentation. Regression to the mean is where really extreme scores tend to sort of regress to what's considered normal or mean or average scores over time, and that's an issue in single system designs as well. That's simply another way to say that really extreme scores are also really extreme events. They happen infrequently. And then, of course, the biggest issue in single system designs is that if there's dropout or attrition, you've essentially invalidated that whole single system design, right? You've got one person in the study. If that one person drops out, as happens in clinical practice, quite frequently, the sort of results of that study are really called into question. So again, I said a second ago that external validity really isn't a thing in single system designs. The thing to do if we were really conducting a research program sort of rooted in single system designs would be replication, to do these things over and over and over and over again. Okay, and of course the other thing is that oftentimes single system designs are based on convenience samples, right? They're people who are themselves presenting for treatment or intervention, and so that would be a vulnerability. So there are basically a number of other threats to external validity that are all sort of limiting the utility of single system designs as research tools. Like I said, they're really clinical monitoring tools, or intervention monitoring tools. But I've listed a few of the threats to external validity up here, and just to run through these, obviously there's an interaction of testing and treatment, right? The combination of pointing out a problem to someone and then treating them probably is going to have really good results, and that's good for the client. It's sort of bad for research. Then there's this thing known as practitioner style, and some clinicians are really warm, or some people just sort of naturally get along, and so the way a clinician delivers an intervention is known as the practitioner style. And then there's this issue of differences in clients and the way that they're going to respond to interventions and treatment. And then there's the simple fact that oftentimes when clients present for treatment, they have multiple dependent variables or multiple problems that really need to be the source of attention. So if we start to measure all of those things, we start to really interfere with their life. That's that obtrusiveness thing that I mentioned in the beginning of today's talk. But you also sort of have more and more risk for a testing effect. If you remember from last semester, reliability is really this issue of findings being replicated over time and being sort of replicated with some degree of consistency over time. And so the question in single system designs is, can the effects of an intervention be replicated over time and across populations? It's hard to do, and that's one of the real limitations of single system designs in research. As I've said, again, I don't mean to repeat myself, but just for emphasis, as I've said, single system designs are really about sort of monitoring interventions. So despite all of these sort of shortcomings of single system designs, they do have a number of advantages. They're adaptable. They're really they can be used with just about any person, of any age, with just about any problem. They can be used in sort of any setting as well. Like I said, they're widely used in healthcare and healthcare adjacent fields. They contribute something to treatment. They don't really detract or disrupt from it. And they're really sort of focused on the individual. So they're very, they generate a lot of insights for an individual. And then they also don't really require, many resources to sort of implement or analyze. I did put, it doesn't require a computer. Hypothetically it doesn't. You could graph it with a piece of graph paper if you wanted to. We're using Excel in this class because it makes life a little bit easier, but hypothetically that could be done. And I've actually seen clinicians create a graph just on a blank sheet of paper, and sort of graph a client's report of problems over time. So that is something that, again, if it's clinically indicated, can be done. But again, the disadvantages, just to sort of highlight these for you, is that there's really no external validity. There's little control over the length of phases. That's often done as a function of what's clinically indicated. And they do, again, have these sort of these kind of ethical limitations. The designs with higher levels of validity, like the AB design, or things that are more complicated, are often ignored by clinicians because they do sort of bring in these ethical limitations, and clinicians are generally interested in treatment, and sort of as they should be. Single system designs aren't exempt from any of the ethical issues that we talked about. Informed consent is still a thing. That's a thing in research. It's a thing in treatment as well. Participants have to sort of consent to being treated. And then in sort of the most faithful implementation of a single system design, participants have to understand that the onset of the intervention is going to be delayed because you've got to have some multiple measurements of that baseline intervention. So I will end this lecture here. Thanks for watching.